So, in this video, we will explore, so to speak, the perspective whereby a term is viewed as a certain kind of a function from the domain to the domain. Now, for constant terms, these just denote whatever they denote, so in a sense, the mapping here will just be the constant function, right? Given any element out of the domain or collection of elements out of the domain, then it will simply always map to the same one thing, right? So a constant is a constant term is kind of viewed as a constant function into the domain. Now, if we have some variables and we make a list out of them, we have m variables, and each one has its own index, I sub 1, I sub 2, so on, then we can view each variable as basically the identity function, mapping whatever we feed in is just equal to the thing that we feed out of the function. So kind of like f of x equals x in that sense. So and then finally, for function symbols, we view a function symbol as mapping an appropriate length tuple, right? Something out of the m-length product of sets into the domain. Now, we would like to make this whole concept rigorous, so again, we do an inductive definition. We suppose that S is any subterm, technically. I mean, we could just regard that as an extremely technical specification. Every term is a subterm of itself and so on, but also you could have some subterms of a given term. So, if we suppose that S is any subterm, we take any tuple out of the m-length product of the domain, we inductively define what this term maps the tuple to. Now, as I said, for constants, if this term is a constant symbol, for whatever domain or for whatever structure we're working with, it just always maps that tuple of elements just to the denotation of C. So that's just reflecting that constants come out in this analysis as a constant function, or determining a constant function. Variables will just, really more than the identity function, these are more like the projection function, so that given this list A sub I sub 1 through I sub m, we just select out, where if V is ij, then we select out the ij term, so that in that way, V sub ij is the projection function on the tuple of A. So, next, and those are the base cases for the inductive case, supposing that we have a function symbol that has m coordinates, then this term on the given tuple is identified with the function that the function symbol represents, using the mapping on that we assume we already have from the component terms. And in this way, we have every term representing a function from an m tuple of the domain to the domain.